This is Professor Derf Seitz. This Java tutorial is Exceptions Part 1, Exceptions in the Wild. This class is called Exceptions in the Wild. It has several functions in it that will cause exceptions. There are two types of exceptions, and they're unchecked or checked. This example will create 4 unchecked ones and 1 checked exception. An exception is an event that happens that disrupts the normal flow of control, and they're usually unwanted. However, sometimes they're part of the plan, such as an end-of-file exception, which we don't have in this example. They usually require some kind of handling or corrective action because they could indicate a logic problem or a programming bug. Let's go through the functions here and see these sample exceptions, and then we'll run this program. First, we have a function called doArrayIndexOutOfBounds. There's an array, has size 7, and we reference its index 7, which is too big because the indexes are 0 through 6. That will cause an array out of bounds exception, array index out of bounds exception to occur. Another function, do divide by 0 floating point. Here we divide a floating point number by 0. This actually, although you think it would cause an exception, it does not, because floating point numbers have some special values, one of which is not a number, another is infinity, and special values can be set to allow these kind of things to happen with floating points. Next we have do divide by 0 integer. This will cause an arithmetic exception, a divide by 0 exception, dividing an integer by 0. Next we have a file not found. The function is called doFileNotFound. We have a file here and we're giving it a name for a file that does not exist, and then we try to use that in a scanner object. This one is a checked exception, and that's why we had to put this special clause in here, throws file not found exception. If we comment this out, this throws, then we get a syntax error here. It says unreported exception. It must be either caught or declared to be thrown. This is the rule for all checked exceptions. Checked exceptions, the compiler is going to make sure that you either take care of it yourself, or you have to declare through this throws clause that I'll uncomment that you're not going to deal with this in this function, and someone else has to deal with it. So anyone using this function should look at this and say that this exception can happen, and they need to themselves either handle it or declare that they're not going to handle it either. So for now, we're just saying we're throw this exception. That's the terminology. You throw the exception. It's like a hot potato. You throw it to someone somewhere else. It's too hot to handle. Go down, do input mismatch. Here we have a string, a plus 7.7. We instantiate a scanner and we start parsing this string, and right away we want to do a next double. Well, a is not going to work. That's an input mismatch, and we'll have an exception. We won't even get to the point where we'll try to do the next to get the plus sign for the operator and the next double to get the 7.7. As soon as you get an exception, we'll see that the program is going to have a problem at that point. Down here we have a do nested divide by 0, and it's got a 1 after it because it calls do nested divide by 0.2, and that calls do nested divide by 0.3, and that calls the original do divide by 0 integer, which does cause an exception. We'll see here what happens when you're calling down what's called the call stack several methods down, and you get an exception. Finally, we have a do no such element, and this will generate a no such element exception. Causes one of those. And it also has an expression and tries to parse it. However, it can get the 1 okay for the first operand, and it can get the plus sign, but it's going to run into trouble because there's no other token to get, just white space, and so that's why it will get a no such element exception occurring. So there's the exceptions in this class, exceptions in the wild. The client class that uses it is over here. It calls these functions one by, well, first it instantiates an exceptions in the wild object called exception source, and then it's going to use that object to call these functions one by one. And it says here, the comment says, to test, selectively comment out the following calls. First we'll leave them all uncommented and see what happens. Notice here that we're throwing the file not found exception as well, because we're not handling it. If we don't declare it, if we comment that out, also we'll get a syntax error here, because again you must either catch a checked exception or you have to put a clause in the function where it occurs saying that you're not handling it. It might be thrown to someone else. Okay, so we've made some changes. I have to save this, commenting and uncommenting. Let's take our first run here, run it, and right away we see the Java runtime is displaying an exception has occurred here. An array index out of bounds exception has occurred. Let's close this, and we see that was our first call, array index out of bounds. Nothing else happened. The program stopped right there and crashed because there was no handling of it. Let's comment out that one, save it, and run it again. Our next is do divide by 0 floating point. Remember, that will not actually cause an exception. And after that is a do divide by 0 integer, which will. We run it again. Here's our output from our floating point divide by 0. It produces a result called infinity, which is a double value, special double value. But then when it tries to do the divide integer, we get an arithmetic exception with the message slash by 0, divide by 0. Close that out. Let's comment both. We'll leave the do divide by floating point in there because it's not throwing an exception, so we can see that. Get rid of the divide by 0, save it. Next we should get file not found. We run it, and here we see it says file not found, no such file.txt. The system cannot find this file. So that happens, and notice after it there we see intermixed with its output this floating point divide by 0 result. That's interesting that it's intermixed there. Must be some timing issue with this particular thing. We'll close the window and comment out the file not found, save it. Next is a do input mismatch. Run that, and here's the floating point doing its divide, and then input mismatch exception. Program blows up because it wasn't handled. Close that, and comment that out. Next is no such element. Run it, and there's the no such element exception. All these lines here are called the call stack. It's taking from the original place in main where we called do no such element, which it in turn did a next double, and that did a next, so it's showing all the different calls that go down, starting with our code, going all the way down into the Java class library, and that's called the call stack because you're stacking the calls on top of each other. Our next example here will show that better. Let's close this one, comment that out. So this next example is the do nested divide by 0, where there's a number of calls involved. We'll run it, and here we see in our main method where we started, we first called do nested divide by 0, 1. It calls do nested divide 0, 2, and then 0, 3, and then the actual call of do divide by 0 integer, and we get an exception, an arithmetic exception there. We'll close that down, and this shows what it looks like when some exceptions happen in a program that you don't do anything about. And to review, remember that some of them were unchecked. The compiler does not force you to do anything with them. As we've seen, they can cause your program to crash, and many times it's actually an advantage because many of these are due to programming errors like that index out of bound. You don't really want the program to continue running. It could be going over into memory it shouldn't be and producing without crashing. It could be causing a lot of real problems in whatever application it's running in. So it's better for it to actually crash when it has these kind of problems, so it can be stopped and investigated and fixed. The checked ones, on the other hand, usually represent things that should not cause a program to stop, that should be handled as part of the code, like a file not found. Perhaps it's because the user's entering a file name and they picked a name that's not really there, and you want to give them another chance. So this concludes our observations of exceptions in the wild.